Hey everyone, this is the follow-up video to Guess That Number. Um, this is more of the explaining how the math actually works so that you always end up with the same answer of 1089, no matter what three-digit number you choose, as long as those three digits are different. So originally in the video, at the very last part of it, I chose the number of 012 as my three-digit number, and then when I reversed it, I got 210. Now, because the 210 or 210 is greater than the 012, that becomes the number that you're going to subtract from. So we have 210 minus essentially 12, or 012. Now, what I did over here was I took those numbers and I just turned it into um, more of a representation of any three-digit number. So I have XYZ and ZYX. So XYZ is going to be under the or is going to be on top because we need to have the assumption that X is going to be greater than Z. Because if it wasn't, then we would have a negative number when we actually did our subtraction here, and we don't want that. So greater number has to be on the top, then you subtract the lesser number. So if we were to do subtraction here, I'll represent it here, and step by step, I will then represent it over here. So if we were to look at this, we have 0 subtract 2 from the ones column. Now, we don't have any ones, so we can't subtract two ones out. So we have to regroup. So we go to the tens column, and what we're going to do here is we're going to take away 110, so that leaves us with 0 tens, and 110 makes 10 ones. So we're going to put 10 here. Okay? Now we can actually do the subtraction of 10 ones minus 2 ones gives us 8 ones. Now if we were to go over to our representation, our x, y, z, and zy, x, we would do the same thing. Since we know that z is less than x, or x is greater than z, we know we can't do z subtract x. So again, all it is your regrouping that we've already done over here, and we know how to do this. So this y in the tens place is actually y, and it's minus 110. So now we take that 110 and we're going to add it to our z. So 110 is actually 10 ones. So now we have z plus 10. Okay. So now we know that the z plus 10 is more than the x, so we do z plus 10 subtract x, and we have z plus 10 subtract x. Okay. Now, I'm going to switch colors here. Now we go to our tens place, and we're going to go back to our original numbers that we were working with. So we have 0 tens subtract 110. Again, we're in the same situation where we're trying to subtract more than what we have in that particular place value. So we're going to take 100 away. So we're going to take 100 away, and we're going to change that into 10 tens. So we're going to put a 10 here. Now that's 10 tens minus 110, and we get a 9. So we do the same thing here, where y minus 1 is less than y. So we need to regroup. So we take the x, we do x minus 100. And then we take the 100 and we group it to 10 tens. So this becomes y minus 1, y minus 1 plus 10. And if we have minus 1 plus 10, that's actually like saying we have a plus 9. Okay, that's a y, not a 4. Okay, so y plus 9. Now we can do y plus 9 minus y. So if we were to do that, the y's, they cancel out, and we're left with a 9 in our tens place. Okay, come back here, basic, 1 minus 0, you get 1. And it's 100 minus 0 hundredths. Now we have x minus 1 hundredths minus z. So we're just going to fill that in with x minus 1 minus z. Okay. Now, the next step was to reverse the digits and then of the difference and then add them. So that's exactly what I'm going to do. I'm going to reverse. So this becomes 8, 9, 1. Okay. And then when we add it together, we get 8 plus 1 is 9. 9 tens plus 9 tens give us 18 tens, so we know that's actually 8 tens and 100. So we're going to put the 1 up here to regroup. And now we have 1 and 1 is 2. So that's 2 hundredths plus another 8 hundredths. That gives us 10 hundredths or 1,000. And voila, we came up with the 1,089. Now let's see what happens when we do that over with our representation with the letters. So if I go and reverse this, we have z plus 10 minus x. And then I have, well, when we reverse, 9 is 9. Oh, isn't that interesting? It's identical to the tens place over when we use the numbers. And then reverse the hundreds into the ones place. 1 minus z. Okay, fantastic. And now let's see what happens when we add all this up. Well, let's take a look at just this right here. I'm going to separate this with a dashed line just to separate place values so we can see it a little bit better. Okay. So now if we were to add the z plus 10 minus x plus x minus 1 minus z, we can see that we have a positive z and we're adding to a negative z. So therefore these cancel out. This is going to cancel out here. And then we have a negative x and we're adding an x, so those would cancel out as well. And now we have 10 and we're adding a negative 1. So that's just like saying 10 minus 1, and that ends up giving us 9. And now we have the same thing that we had over here with the tens place, so we have 9 plus 9, and that, or 9 tens plus 9 tens, that gave us 18 tens. So we have 8 tens, okay, and would give us 100 over here. So this would be like saying, all right, now we have a 1 that we're adding on top of this. So now we have, let's take a look before we include the 1 that we regroup from the tens place. We did x minus 1 minus z plus z plus 10 minus x. So same thing, we're going to look. We have x, positive x here, and a negative x. So that's going to cancel out. We had a negative z plus a positive z, so that ends up canceling out. We have a 1, and then we had a negative 1, so positive 1, negative 1, that cancels out. And now we're just left with 10. And there you have it. So the letters, the variables that we're using to represent these particular digits, as long as you follow the steps, this proves that any 3 digits, as long as the digits aren't the same and you follow the steps that were given in the other video, you will always come out with the answer of 1089.